I, Mr. Yogesh, Faculty of Mathematics. Is in the mathematics we had already chapter first as a sets. Now we are going to discuss about chapter second, relations and functions, and it is your first lecture. So keep in mind, relations are totally depends upon your sets. Nextly, functions are totally depends upon your relations. And next we have a three chapters, limit, derivative and integration, that are totally depends upon your functions. So first be prepared for sets and relations as well as functions. So in this lecture we are going to discuss about introduction, ordered pair, Cartesian products of two sets and examples. So here is your introduction. In our day-to-day life, we come across many relations such as brother and sister, father and son, teacher and students. In mathematics also, we come across many relations such as number m is less than n. We may say number m is greater than n. We may say m is less equal n, m is greater equal n, or m equals to n, like that. Nextly, line L is parallel to line M, or we may say line M is perpendicular to M, or line L and M are intersecting lines. Next we have a is in case of sets, set A is a subset of B. We may say A union B, intersection B, complement also. So that are the relations in case of mathematics. In all these, we required pair is there to relate them. So we notice that a relation involves pairs of objects in certain order. In this chapter, we will learn how to link pairs of objects from two sets and then introduce relations between the two objects in the pair. So nextly we have ordered pair. A pair A comma B, we have a coordinate system also is in case of 8, 9, 10 standards and all. So a pair A comma B of numbers such that the order in which the number appears is important is called an ordered pair. Ordered pairs A comma B and B comma A are different, keep in mind, that are not equal. In ordered pair A comma B, A is our first component and B is our second component. Note that if any two ordered pair are equal, then their first component should be equal and their second component should be equal respectively. So if we have given A comma B is equals to C comma D, that happens if and only if A equals to C, that means first component should be equal, and B equals to D, that means second component should be equal. Second note we have, if A comma B that is equals to B comma A, this happens if and only if A equals to B. Nextly we have a few remarks. First remark, two ordered pairs are equal if and only if the corresponding first element are equal and the second element are also equal. We have it is in the note. Second remark we have, if there are P elements in A and Q elements in B, keep in mind again A and B are the well defined sets, there will be P into Q elements in A cross B. That is, if number of elements in A equals to P and number of elements in set B equals to Q, then number of elements in A cross B that is equals to P into Q. That A cross B defines your ordered pair. Third remark we have, if A and B are non-empty sets and either A or B is an infinite set, Then so is A cross B. Here is one example. If x comma y equals to A comma B, that implies x strictly equals to A and y is strictly equals to B. Nextly we have Cartesian products of two sets. Let A comma B be the any two non-empty sets, the sets of all ordered pairs A comma B, such as A belongs to capital A and small b belongs to capital B, is called the Cartesian product of the sets A and B, and it is denoted by A cross B. Thus, A cross B is equals to, that means Cartesian product of A and B is equals to sets of all elements of the form A comma B such that small a belongs to capital A and small b belongs to capital B. What happens if both are the empty sets? If A is your empty set or B is your empty set, then we defined Cartesian product of A and B is equals to again phi, that means our empty set. We have one example. Let us assume that set A having an elements A comma B comma C and set B having an elements P comma Q. Then how to find that Cartesian product of A and B? The Cartesian product of A and B is given by ordered pair of each and every elements that are relates from A to B. Keep in mind, because here A comes first, so we get it is the sets of first ordered pair A comma P, A comma Q, B comma P, B comma Q, C comma P and C comma Q. What happens if we have to find that Cartesian product of B with respect to A, or B is relates with the A? We may say that is equals to is in the curly braces again. Let's start first element of B is related with the first element of A and so on. So it is P comma A, P comma B, P comma C. Nextly Q comma A, Q comma B and Q comma C. So whenever we have to find Cartesian product of A and B, so A come first. So first element must be belongs to our set A and that relates with a set B. So how to find that Cartesian product? Just concentrate here. First element of set A is relates with a first element of set B. Next, first element of set A is relates with a second element of set B. Next, take it out that second element. Second element of set A is related with a first element of set B. Then second element of set A is related with a second element of set B. Third element of set A is related to first element of set B. Third element of set A is related to second element of set B, and so on if there are n number of elements. So here is the diagrammatic representation. We have another example. You may try that Cartesian product like way. So A having an elements x, y and z, set B having an elements 1, 2, 3. So is in the first cell we have x comma 1 because we have to find here A cross B, Cartesian product of A with respect to B. Next element, second cell is in the first row we have x comma 2, then x comma 3 is in the second row. First element we have y comma 1, y comma 2. Likewise, we may prepare that ordered pair by using table format also. Next one, we have a example. If x plus 4 comma y minus 4 is equals to 3 comma 1, find the values of x and y. So whenever two ordered pairs are equal, then their first component should be equal and their second component, or we may say element, should be equal. So we have x plus 4 equals to 3 and y minus 4 equals to 1. So both are the linear equation in one variable. So how to simplify that? X plus 4 equals to 3. We have to shift that 4 from LHS to RHS. After shifting, it changes its sign from plus to minus. So it gives us x is equals to 3 minus 4 is minus 1. Likewise for y minus 4 equals to 1. As we will shift that 4, it gives us y equals to 1 plus 4 is 5. So our x value is minus 1 and y value is 5. Next example we have, if set P having an elements a comma b, set Q having an element R, so keep in mind it is your singleton set, form the sets P cross Q, that means Cartesian product of set P and Q, or we may say P with respect to Q, and Q cross P. Are these two products equal? So our answer, by definition of Cartesian product, we can easily evaluate P cross Q. So first element of P is relates with R. Then nextly second element of P relates with R, that gives us sets of an element A comma R and B comma R. What about that Q cross P? So R is relates with the first element of P. Nextly R is relates with the second element of P. So it gives us sets of an ordered pair elements R comma A and R comma B. Since by definition of equality of ordered pairs, the pairs A comma R is not equals to the pair R comma A, so we conclude that here Cartesian product of P with respect to Q is not equals to Cartesian product of Q with respect to P. That means P cross Q is not equals to Q cross P. However, the number of elements in each set will be the same. Next example we have, set A having an elements 2, 4, 6, B having an elements 3, 5, and C having an element 5 only. So find first A cross B intersection C. So for finding Cartesian product of A with respect to B intersection C, first of all we have to evaluate B intersection C. So what is meant by intersection? Common element, or we may say same elements between A and B. Which are they? It is 5. So B intersection C is equals to the sets of an element 5. So nextly we have to find A cross B intersection C. So first element of A relates with a 5. That means we get first ordered pair as a 2, 5. Next 4, 5 and likewise 6, 5. So A cross B intersection C having an elements which are is in ordered pair, keep in mind 2, 5, 4, 5 and 6, 5. Nextly we have to evaluate A cross B intersection A cross C. That means Cartesian product of A with respect to B intersection Cartesian product of A with respect to C. So how to evaluate it? So first of all try to evaluate for A cross B. So that gives us sets of an ordered pair 2, 3, 2, 5, 4, 3, 4, 5. Likewise for 6 also 6, 3, 6, 5. Nextly we have to evaluate for A cross C. So how to get that? First element of A relates with a 5. Second element of A relates with a 5. Third element of A relates with a 5. That makes sense sets of ordered pair 2, 5, 4, 5 and 6, 5. So what is the intersection between A cross B and A cross C? That means common ordered pair here. Which are they? 2, 5, 4 comma 5 and 6 comma 5. So it is your answer. Next we have to evaluate for A cross B union C. So for that we have to evaluate first B union C. So what is mean by union? Sets of all elements that are either belongs to B or C or both. So which are they? 3 and 5. So how to get that A cross B union C? That means Cartesian product of A with respect to B union C. So first element of A relates with a 3. First element of A relates with an actually 5. Next, second element of A relates with the first element of B union C. Second element of A relates with the second element of B union C, and so on. So we get that ordered pairs of the form 2 comma 3, 2 comma 5, 4 comma 3, 4 comma 5, 6 comma 3 and 6 comma 5. Next example we have within it A cross B union A cross C. So firstly evaluate for A cross B and A cross C, which we have is in the second sub question. So we have to find it's a union. So all elements that are either belongs to A cross B or A cross C or both. So which are they? That are the ordered pairs of the form 2 comma 3, 2 comma 5, 4 comma 3, 4 comma 5, 6 comma 3 and 6 comma 5. So here is our result. A cross B intersection C, that is equals to A cross B intersection A cross C. Nextly, second result we have A cross B union C, that is equals to A cross B union A cross C. So next example we have if P equals to sets of an element 2 comma 4 form the set P cross P cross P, that means Cartesian product of P and P and P. So here is your answer. We have P cross P cross P is equals to sets of 2 comma 4 cross sets of 2 comma 4 cross sets of 2 comma 4. So how to evaluate that this type of Cartesian product? Look at once. So let's start with the first element of first set is relates with the first element of second set is relates with the first element of third set. Then nextly let's start with the first element of first set, first element of second set and second element of third set, and so on. So we get ordered triplet here is of the form 2 comma 2 comma 2, 2 comma 2 comma 4, 2 comma 4 comma 2, 2 comma 4 comma 4, 4 comma 2 comma 2, 4 comma 2 comma 4, 4 comma 4 comma 2 and 4 comma 4 comma 4. So Cartesian product of real with itself is denoted by R3 and it is given by A cross A is equals to sets of an ordered triplet of the form A comma B comma C such that A comma B comma C must belongs to the given set A. Here A comma B comma C is called an ordered triplet, or we may say three-dimensional spaces. Again keep in mind we have is in the ordered pair. If A comma B we have given and that A comma B is not equals to B comma A. Likewise for three-dimensional spaces also A comma B comma C is not equals to B comma A comma C, and that not equals to C comma A comma B also. So we have a next example if A cross B, that means Cartesian product of A with respect to B is equals to sets of an ordered pair x comma P, x comma Q, y comma Q and y comma P. So find A and B. So how to evaluate that? Look once. So all first element, or we may say first component of the given ordered pair is our first set. So set A is given by which are the first element, or we may say first component of the given ordered pair is in the set A cross B, that are x and y. So our first set A to be x comma y. Similarly, second component are belongs to our second set B. So which are the second component? P and Q. So set B is given by P comma Q. So nextly we have a important theorems on Cartesian product of sets. So first theorem already we have is in case of examples. For any three sets A comma B comma C, first we have A cross B union C, that means Cartesian product of A with respect to B union C is equals to A cross B union A cross C, that means Cartesian product of A with respect to B union Cartesian product of A with respect to C. Second we have A cross B intersection C, that means Cartesian product of A with respect to B intersection C is given by Cartesian product of A with respect to B intersection Cartesian product of A with respect to C. Second theorem we have for any three sets A comma B comma C, Cartesian product of A with respect to B minus C is equals to Cartesian product of A with respect to B minus Cartesian product of A with respect to C. Third theorem we have if A and B are any two non-empty sets, then Cartesian product of A with respect to B is equals to Cartesian product of B with respect to C if and only if, keep in mind, whenever it happens, then our given two sets should be equal, that means A equals to B. Theorem 4 we have if A is a subset of B, then A cross A, keep in mind, that means Cartesian product of A with respect to A is the subset of Cartesian product of A with respect to B intersection Cartesian product of B with respect to A. Fifth theorem we have if A is a subset of B, then Cartesian product of A with respect to C is subset of Cartesian product of B with respect to C for any set C. Sixth theorem we have if A is a subset of B and C is a subset of D, then A cross C is the subset of B cross D. Next theorem we have for any three sets A comma B comma C comma D, we have A cross B intersection C cross D, that is equals to A intersection C cross B intersection D. Eighth theorem we have for any three sets A comma B comma C, first we have A cross B complement union C complement ZA complement is equals to A cross B intersection A cross C. Nextly we have A cross B complement intersection C complement ZA complement is equals to A cross B union A cross C. So in this lecture we have ordered pair and few remarks that are depends upon our ordered pair. Nextly Cartesian products of two sets. Within it Cartesian product of real with itself also, and important theorems on Cartesian product with few examples. So here is your homework. Let's try question first and question 6 from exercise 1.2. Keep in mind here we are referring target publication. Is in our NCERT syllabus we have a separate chapter for relations and functions, but is in case of target publication we have a combined chapter of sets, relation and functions. So here is your exercise 1.2 which is depends upon your relations and functions. So is in the next lecture we'll learn about relations, what is meant by relations and all, introduction of relations and types of relations and their examples. Thank you.